Hello again, welcome to another lesson in geometry. We are covering section 12-5, circles in the coordinate plane. So this is our last section we're going to cover out of chapter 12. And this one's no longer about all the little angles and chords and secants and tangents. This is just about the equation of a circle on the coordinate plane. Okay, so a little bit different, but it still goes with circles. Okay, so write true or false for each one. The coordinate plane extends without end and has no thickness. This is true. Only lines can be graphed in the coordinate plane, and this is, of course, false. We're going to graph some circles today. We've also graphed parabolas and other shapes in the past in your math career. Any polygon can be plotted in the coordinate plane. This is true. We did this when we were doing isometries. 0, 5, and 5, 0 are the same point in the coordinate plane, and this is false. If it was the same point, it would have the same coordinates. This first one says go left and right 0 and then up 5, and the second one goes right 5 and up and down 0. All right, so the coordinate plane is three-dimensional. This is false. You can draw a three-dimensional coordinate plane, but that's not the basic one. Okay. You can find the slope of a line in the coordinate plane, and this is, of course, true. You spent half of Algebra 1 doing that. All right, vocabulary builder, standard form. So main idea is the standard form of an equation gives information that can help you graph the equation in the coordinate plane. So the standard form of an equation of a circle is this. It's x minus h parentheses squared plus y minus k parentheses squared equals r squared. And the standard form of a linear equation is ax plus by equals c. So you can see it's kind of similar. Okay, the r squared is going to be a number just like it was for the c and standard form of a linear equation. But a circle, we're going to have some squares in there, not just x and y. And then we're also going to subtract some parts off. So you also did the standard form of a quadratic equation. That was y equals ax squared plus bx plus c. So just think of the circle as just another standard form, and this graph of it will make a circle as opposed to a line or a parabola. All right, and then the h and k in here are going to be important. They're going to tell you about how to find the center of your circle, and the r, of course, is going to be our radius. All right, so use your vocabulary. Draw a line from each equation in column A to the standard form in column B. So y is number 7 here, y equals 2x plus 3 is in slope-intercept form. In standard form, we'd have to move the x to the other side. So we would have maybe negative 2x plus y equals 3, but that's not on our list. So we can flip all of the signs and make it positive 2x minus y equals negative 3. Okay. Number 8, this one's also in slope-intercept form, so we're going to move the x part over. So we get something like this, negative 3/4 x plus y equals negative 2, but obviously that one's not on here. So we'll times everything by 4. This will give us negative 3x plus 4y equals negative 8. That one's still not on here because they wanted to use the positive, so they multiplied everything by a negative. So that's going to be this one. Number 9 is much easier to do. You just add x to the other side, and we're going to get x plus y, and that leaves 0 on the right side. And in our last one, we can just move the 3 to the other side. So we're going to get negative 3 equals 2y minus 4x, but we got to flip all the signs, so we'll make it 4x minus 2y equals positive 3. All right, let's flip it over and check out the second page. Theorem 12-16, equation of a circle. So the equation of a circle with center at h and k and radius r is just what we saw on our other page. X minus h in parentheses squared plus the quantity of y minus k squared equals the radius squared in this case, because r is going to be our radius. So complete each sentence with center, circle, or radius. So each point on a circle is the same distance from the center. Okay. So all the points on the blue circle here are all the same distance from the center HK. The equation of a circle with center at negative 1, 0 and a radius of 6 is as follows. So the 6 is the radius, therefore it's 6 squared on that side. Each point on a circle is r units from the center. So that point is 6 units away from here. This point is 6 units away, this point 6 units away, this point is 6 units away. And the distance formula D equals x to the x2 minus x1, so the difference in the x coordinate squared and the difference in the y coordinate squared. Remember, it doesn't matter who you pick for x2 or x1 in this formula. So how is D in the distance formula related to the radius r in the standard equation of a circle? So let's see. Here's a sample answer. The radius r is the distance D between center HK and XY on a circle. Okay, and is also the hypotenuse of a right triangle with vertices HK, that's our center, XY, that's our current point, and then X minus H and, Y minus K. All right, so X minus H and Y minus K. All right, so let's see what that's talking about here. All right, so here's XY, here's HK, and we can form a right triangle out of those. And you can see this point right here is going to have the height of whatever X is minus the H the left and right value of that. And then the height of whatever Y is minus however tall K is up. Okay. All right, so we're going to form a right triangle in this, and that gives us our distance, which is the radius. Okay, so the distance formula helps us find our radius. How are the distance formula and the standard formula of the equation of a circle alike? So here's a sample answer. The standard form of the equation is the distance formula using XY on a circle and center HK of the circle. Okay, the distance is the radius of the circle. So it keeps using that same distance and finds all the points that are that distance away from HK. So it finds the radius and finds all the points that are that radius distance from HK, and all those points are our XYs that we're going to graph. All right. So write the equation of a circle. What is the standard equation of a circle that has a center of 3, 5 and a radius of 6? So this is HK, and this is R. So the X coordinate of the center is H, okay, which is 3. And the Y coordinate of the center is our K, which is 5. So is the standard form of equation X minus H squared plus Y minus K squared equal to D? And this is no. It's not supposed to be a D here, is it? Okay, identify the values of H, K, and R. So we know that H is 3, K is 5, and R was 6. So write the equation in standard form of the circle with 3, 5, and a radius 6. So the center is 3, 5. So it's X minus 3 squared, Y minus 5 squared, and then 6 squared. Okay, so that's going to stay X minus 3 and Y minus 5, but this will just turn into 36. Problem 2, using the center and a point on a circle. So what is the standard equation of the circle with the center 4, 3 that passes through the point -1, 1? Complete the reasoning model below. So HK is 4, 3. That's our center. And -1, 1 is a point on the circle. So we have to find the radius R. Okay, all we needed was the center, which we already have, and the radius, and then we can write the equation. Okay, so the standard equation of a circle to help us get it. And then the plan is x minus h squared plus y minus k squared equals r squared. So we need to get those parts to put it in. So we're going to use the distance formula to find r. And then we're going to substitute h, k, and substitute for h and k and for r into our equation. Okay. So we'll start with the distance formula. So all we need to do is find the distance between the center and one point on the circle. And that would be our radius. So we'll use our formula, x2 minus x1, y2 minus y1, both of them squared, add them together and square root. That'll tell us our distance. So it's 4 minus negative 1 squared and 3 minus 1 squared. 4 minus 1 is 5. 5, we're going to square that. And 3 minus 1 is 2, and we're going to square that. So this will give us 25 and 4. So we're looking for the square root of 29 as the radius. Now write this equation in standard form. Okay, so we have x minus the x coordinate squared plus y minus the y coordinate squared for our center. So here's our center, so that's our h and our k. And then we have equals the square root of 29 squared. So this is x minus 4 squared plus y minus 3 squared equals, and oops, we were supposed to put in our formulas here, use the standard form of the equation. So x minus h squared plus y minus k squared equals r squared. Then we put in 4, 3, and the square root of 29. Okay, so this is x minus 4 squared, y minus 3 squared, and then the square root and the square will cancel out. So we get our radius squared is 29. Remember in our formula, it's not the radius it's equal to, it's the radius squared that it's equal to. All right? So given a circle, graphing a circle given its equation. So suppose the equation of x minus 7 squared plus y plus 2 squared equals 64 represents the position and transmission range of a cell tower. So the 7 and negative 2 tells us its position on the coordinate plane. And the radius, 8 squared in this case, tells us the transmission range of the cell tower. So the radius is 8. What does the center of the circle represent, and what does the radius represent? So we'll place a check in the box if the response is correct, and an X if it's incorrect. So the transmission range is the same distance all around the cell tower. This should be correct. Now, obviously, if there's a mountain or something in the way on one side, it's not going to work, but hopefully they didn't build it so that it would be blocked on one side. That's why you see towers up on top of hills or on top of buildings. Okay, so the center of the circle represents the position of the cell tower. This is also correct. Okay, the center of the circle represents the transmission's range. This would be no. Center tells us where the tower is located, not the range it can go. The radius of the circle represents the position of the cell tower. This is no. The radius of the circle is our range. And the radius of the circle represents the transmission range. This is yes. Okay. All right, let's flip it over. What is the center and radius of the circle with equation x minus 2 squared plus y minus 3 squared equals 100? And we want to graph the circle. So our center is going to be 2, 3. And the radius squared is 100, so the radius is 10. And now we need to graph it. So let's put our first point at 2 and 3. Okay. And then we can put another point. We need a radius of 10. So that's going to be here. This is 10 away. And then 10 away up here will be at 13. And then 10 away back here would be at negative 8. And 10 away going down would be 2, 4, 6, 8, 10 right here. Okay. Now at this point, you should take out your compass to draw in the circle. So I found some points using our center and our radius. Okay, but I can't do them all with that, so I'm going to take out my compass and draw in the circle the rest of the way. Okay, and there we go. All right, so there is our circle. I'm a little bit off on the circle, but you get the idea here. Okay, All right, so as always, pause the video, try the lesson check yourself. Okay, welcome back. So our lesson check is a do you understand lesson check. And the directions are, suppose you know the center of a circle and a point on the circle. So our center, you know, is going to be our HK, and then we know some other point XY at a random place on the circle. How do you determine the equation of the circle? So first off, do you know the value of H? This is going to be yes, of course. They told us the center of the circle. Do you know the value of K? And this should also be yes. They told us the center of the circle. And do you know the value of R? And this is going to be no. They did not tell us the radius. They just told us another point. So how can you find the missing value? All right, well, that's easy. We did it earlier in the notes. We just find the distance between the center and the point we know. Using the distance formula. Okay, remember our distance formula is d equals to the square root of x1 minus x2 squared, or x2 minus x1, it doesn't matter, plus y1 minus y2 squared. All right. Once you know hk and r, because r is going to be our distance here, how do you determine the equation of the circle? So this is really easy. You just plug hk and r into the circle formula. Okay, which was what? X minus h squared plus y minus k squared equals the radius squared. The tricky part is to remember that it's the radius squared on the end, not just the radius. All right, that concludes our lessons. And the last lesson we're going to do for chapter 12, we don't cover section 12.6. It's not in our standards. So you should be starting to study for the test, figuring out what you need to go back and review. So this lesson was a good bit different. We talked still about circles. We used the distance formula again because we're talking about a coordinate plane, and we found the standard form of circles. Okay, so how well can you use the standard form of a circle? You should be in here. This is not very tricky, I don't think. If you're having some trouble with it, just go back and look through it again. Figure out what that HK and R means in our formula. So next time you should be able to find some radiuses, you should be able to graph some circles, and you should be able to look at the graphs of some circles and write their standard form equation.